Section 11.4 in Algebra 2. Here we're talking about conditional probability. So 11.4, conditional probability. Okay, so this is generally some sort of contingency that could happen. Now there are sometimes we have a contingency table, sometimes we don't. Sometimes we got to look at formulas of what's going on. Do realize that in conditional probability, we generally have some sort of condition that limits down what could be happening. So for instance, ladies, let's say you told a secret, okay? So you told a secret. Now here's all those girls that you could have told a secret to, okay? But this secret was in condition with the basketball team. So I'm going to go B-ball. So basically what you did here is now somebody spilled your secret and told the boy that you liked them, and you only told the basketball team. So rather than trying to figure out, well, out of all these possible girls, hey, wait, only girls on the basketball team knew this. So they had to tell somebody else for them to tell them. But originally they spilled the beans. So now you can go beat up only the basketball team rather than all the girls in the school type thing. That's where this conditional probability really starts going. But then we start taking it backwards, okay? We start taking it backwards and we start tying in that, well, what's the possibility that one of these said it or this other one? So we start seeing that conditional probability really has an overlap with a dependent event, okay? So if we consider a dependent event, okay? So a dependent event, probability of A and B happening was probability of A times probability of B less A. Well, now we're going to say, okay, we know this happened. What's the chance that it had this part here? So we look at the probability of B less A equals the probability of A and B happening divided by the probability of A. One of the biggest things that really happens in here, and one of the main applications I really like to point out, is think about a manufacturing business. A manufacturing business could have machine A and machine B here. Now, machine A produces defective parts at a rate, machine B produces defective parts at a rate. If down the road you find a defective part, what's the chance it came from A or what's the chance it came from machine B? That's what we start looking at. We start saying, okay, now that we found this down the road, we're going to trace it back to what happened before this. And that's where this conditional probability comes in. Once again, that contingency that we found it here. Now, what's the chance it was this versus the chance it was something else as we start relating it? Nothing real big that I can get into besides let's start working at our tables right here. So if we look at number 8 and 10, now number 8 and 10 have this table that is given to us. So looking at our table that we have here, we're talking about the characteristics of job applicants. So we talk about, out of these job applicants, we talk about having a high school diploma, not having a high school diploma, having experience and not having experience. So we see that 54 people have experience and have a high school diploma. 27 have a high school diploma but no work experience. 4 have no experience, no high school diploma. 5 have no high school diploma but they have work experience. So on number 8, they tell us what is the probability that if we pull out of this, that it has a diploma. Okay, so basically if we were to throw all these people into a hat and pull out one person, we would want to know what's the probability that we have a diploma. So if we consider and look at our total amount right here, we see that there are 90 total. So 54 plus 27 plus 5 plus 4 is 90. So we have 90 total applicants all together. And we look at this and we say, well, has diploma, yes and yes. So we see that this is 54 plus 27 right here because we're going to add these categories together. So we see that out of all 90 here, that, let me get a calculator here because my brain is not working for this addition, that 81 out of 90 have a diploma, in which then if we take 81 out of 90, we get 9/10. So we see that there's a 9/10 chance that out of this pool that they'll have a high school diploma. Okay? Now, part 10, or number 10 tells us, what's the probability that they has experience less they has a diploma? Okay? So, this is talking about some sort of contingency, some sort of restriction being put on here. If we have a diploma, that means that we have a little change going on here. Okay, so if we think about this, we have a restriction put on this. Okay, so this is our restriction. Now, I'm going to relate the formula to this, which I did up here, and then I'm going to come back and show you a common sense way to think about it. So if we look at the probability that we have experience and a diploma. So if we have experience and a diploma, that is 54 out of 90. Over now the probability, so once again, probability of A or B, or A and B, divided by probability of A. Once again, this is probably a B less A, so this is my A, this is my B. So the probability that they have a diploma, once again, was that right up here, we did that one prior, 81 out of 90. So if we take 54 over 90, and we 54 over 90, and we divide that by 81 over 90, we see that we get 2/3. Okay? Now, how could we think about this differently? Okay? We can apply some common sense into here. If we think about this as this is our restriction, okay, this is what we're given. How many have a diploma? So if we look at how many have a diploma, was a total of 81. Okay? And then out of this 81, how many have that high school or have experience? We see that 54 out of the 81 have this. If we take 54 over 81, we see that this is 2/3. Once again, multiply reciprocal, the 90s would cancel. 54 over 81. Okay, so when we're given a table, sometimes we can think about this, oh, we want a diploma. So that means we're looking this line right here. Well, there's a total of 90 on this line. Oh, we also wanted to have experience. Okay, 54 out of that 81 have that experience. That's kind of how that table works, but it's not always easily done, so sometimes we have to apply this formula. Now, for you sports bettors out there, okay, so if you want to bet on sports, this is an excellent thing that you could range in, especially for football. We're going to look at number 18, okay? So on number 18, it talks about the football team has a 70% chance of winning. So 70% chance of winning when it doesn't snow. But only a 40% chance of winning when it snows. Okay, so if we start looking at this, we have a 70% chance if it's not going to snow, so good chance of winning. 40%, ooh, probably unlikely. If it snows, we're a crappy football team. Considering this now, it says, well, suppose there is a 50% chance of snow. We want to figure out, well, what's the chance of this team actually winning? Okay, so if we consider what's happening here, this snow is really influencing what's happening up here. So the snow is the main event. Okay, so if I draw a tree diagram, I'm going to look at, I have a 0.5 chance of snow. or I have a 0.5 chance of no snow. Okay, so it's either going to snow or it's not going to snow. There's a 50% chance of snow, so there was a 60% chance of snow. This would be 0.6. This would be then 0.4. Okay, so once again, it's breaking down. There's a 100% chance of either snow or not snow. Okay, on any given day, it's either going to snow or not snow. It's just going to depend upon the chance and favorable what it is. Then we look at the football team. Okay, so let me come with a different color here so you can see that I'm now changing gears. So if we look at this football team now, football team's either going to win or lose. Okay, so if it snows, the chance of that team winning is a 0.4, meaning then that the chance of that team losing is a 0.6. If it does not snow, so now there's no snow, we look at a win or a loss once again, but now they have a 0.7 chance of winning or a 0.3 chance of losing. Okay, once again, in an event, it either is going to happen or it's not going to happen. That's kind of where we start talking about this property in here. They have to add up to be 1. Looking at this now, it asks us basically, what's the probability the team would win? So we got the probability of a win. Okay, so we want to figure out, well, how are we going to win? Well, when do we win? We either win with snow or we win without snow, right? So if we look at the probability of a win with snow, okay, this would mean we would have 0.5 times 0.4. If we look at the probability of a win without snow, this would be 0.5 times 0.7. So we see that this is 0.2. This is 0.35. Now, we could have this or this happening, right? We could either be snowing or not snowing, and then what we're talking about winning off of that. So then we're going to add this together, and we see that we have a 0.55 chance of winning. So that means there's over half chance that this team will still win, even though they play crappy in snow, but because there's only a 50% chance of snow. And that's where you can start looking into and start considering is basically how do we relate to what is going on. Last one we're going to look at is number 25. Okay, so on number 25 here, we talk about transportation. It says you can take bus 65 or 70. So we have bus 65 or 70. Okay, so given these two buses, it says you take the first bus that arrives. So you're standing at your bus stop, and you're either going to take this bus or this bus, whichever one arrives first. Now, bus 65 has a 75% chance of arriving first. There is a 40% chance that the bus 65 picks up passengers. Okay, now there is a 60% chance that bus 79, so 60% chance, bus 79, not 70, this was 79, sorry, picks up passengers. Okay, it says your bus picked up passengers. What's the probability that your bus 65? So you want to figure out probability that your bus 65, given you pick up passengers, okay, is what we're really relating to. So we got to be thinking about this kind of in the scenario that basically you're standing at this stop, okay, so you're standing right here at this stop, and you're either going to take bus 65 or you're going to take bus 79. Okay, so you're going to take one of these two buses right here. Now the chance of you taking bus 65 is a 0.75 chance, leaving a 0.25 chance you're taking bus 79. Because once again, you're going to take the first bus that shows up, and bus 65 is more likely to show up first. Now, if we consider after this, we'll talk about having passengers or not passengers. So I'm just going to go pass or not, and I'll go pass or not. If we consider what's happening here on bus 65, there is a 40% chance that it picks up passengers, leaving a 60% chance that it's not. On bus 79 now, there is a 60% chance that you're going to pick up passengers, so 0.6, leaving a 40% chance of not. So basically, if you're on bus 65, it's going to show up first. You're going to pick up less passengers, so you're going to be less crowded. So it's a better bus just to be on. But if you accidentally miss that bus for something, or this bus happened to show up first, and the route that it takes, it's going to be picking up more passengers. So it could be a gamble that you could be relating to. Or if you see bus 79 there, well, I want to wait for 65. Well, who knows? Maybe 65 already showed up before there. So it's just one of the things we start looking at in here. So when we consider what's happening here, we got to be figuring out what's the probability that it's 65 and passengers divided by the probability of having passengers. Okay, so if we consider 65 n passengers, so 65 n passengers would be 0.75 times 0.4. Once again, probability of this and this happening, 65 n passengers. So we're going to multiply that together. Over then the probability of just having passengers. So passengers happen here, passengers happen here. So we're going to have to take that 0.75 times 4 plus, because it's or this part down here, 0.25 times 0.6. Once again, multiplying my probability to get to just having passengers. Simplifying this, once again, this is just a calculator operation that we'd be doing here. We would see that we would have 2/3, or you'd have 0.667 basically happening here. So as we consider this problem, as we consider it, basically what it's asking us is that there is a 2/3 chance that if you picked up passengers, you're on bus 65. Okay? So even if you didn't know what bus you're on, there's a 2/3 chance that you're on bus 65 if it's picking up passengers, okay? That's kind of what that's relating towards. Once again, it's kind of relating that whole contingency with that conditional probability that we know we picked up passengers. Now we're trying to track it back to a different event that we're relating to. Once again, this bus 65, it breaks up into this, and then, oh, here's our passengers that we start relating to. So this is one of the ways we can start working with it. Do realize this is probably one of the more complicated things in our probability that we will be doing. So good luck.